5 lines of Python can read any barcode or QR code, from a saved image or straight from your live webcam, and hand you back the decoded text. No cloud service, no paid API, no machine learning to train. In this video we are going to use a small library called pyzbar to do exactly that. I will show you the one install gotcha that trips up almost everyone, especially on Windows, then how to decode a QR code from an image, how to read straight from an OpenCV frame, and finally we will build a live webcam scanner that draws a box around the code and prints what it says, in real time. By the end you will be able to point your camera at a product barcode or a QR code and get the value out in a handful of lines. Let's build it. Installation starts with one line, pip install pyzbar. But here is the single most important thing in this entire video, so pay attention, because this is the number one reason people get stuck. Pyzbar is not a pure Python library. It is a thin wrapper around a native shared library called zbar, written in C, and that native library is not bundled inside the pip package. So pip install pyzbar succeeds, but when you actually run your code it can blow up. On Windows, the classic error is a FileNotFoundError saying it could not find module libzbar 64.dll or one of its dependencies. The fix on Windows is to install the Visual C++ Redistributable for 2013, the Vcredist x64 package from Microsoft, which provides the MSVCP and MSVCR runtime DLLs that zbar depends on. On macOS you install the native library with Homebrew, brew install zbar. And on Debian or Ubuntu Linux, it is sudo apt-get install libzbar 0. So the rule is simple, pip install pyzbar gives you the Python wrapper, but you also need the native zbar library on your system. Get that right up front and everything else just works. Now let's actually decode something. The import is the first little gotcha to get right. It is from pyzbar.pyzbar import decode. Yes, pyzbar.pyzbar, the name is doubled, because decode lives in a submodule that shares the package name. Then we open an image, and the easy way is with pillow, from pl import image, and image.open of your file. You pass that image straight into decode, and it hands you back a list. That is important. Decode always returns a list, because one image can contain several codes. You loop over that list, and each item is a decoded object with 4 useful fields. The big one is .data, and this is the second classic gotcha. .data is raw bytes, not a string. So you must call .decode with UTF-8 on it to turn it into readable text. If you print .data directly you will see that little b prefix and quotes around it, which confuses people constantly. The other fields are .type, which is a string like qrcode or EAN13, telling you which kind of code it was, .rect, which is the bounding rectangle, and .polygon, the corner points. So, decode an image, loop the list, and decode .data from bytes to a string. That's the whole pattern. Reading from a file is nice, but the real fun is working with live video, and for that we use OpenCV. Here is a genuinely convenient thing about pyzbar, you do not need pillow at all when you are using OpenCV. Pyzbar happily accepts a NumPy array directly, which is exactly what OpenCV gives you. So you can do import cv2, then img equals cv2.imread of your file, and just pass that image straight into decode. It works whether the frame is full-color BGR or a single-channel grayscale image, pyzbar handles both. The decoded results are identical to before, a list of objects, each with .data as bytes, .type, .rect, and .polygon. This matters because it means the code you write to decode a still image is exactly the same code you will use on each frame of a video stream. There is no conversion step, no bridging between libraries. Imread and decode, and you are done. That seamless handoff between OpenCV and pyzbar is what makes the live scanner we are about to build so short. Alright, this is the star of the show, a live webcam barcode scanner. We open the camera with cap equals cv2.videoCapture of 0, where 0 is your default camera. Then we run a loop. Each pass, we call cap.read to grab a frame, and we pass that frame straight into decode, because remember, pyzbar takes the NumPy array directly. Now for every barcode the decoder finds, we want to draw a box around it and label it. Each result has a .rect, which is a named tuple with 4 fields, left, top, width, and height. To draw the box with cv2.rectangle, the top left corner is left, top, and the bottom right corner is left plus width, top plus height. Then we pull the text out with .data.decode UTF-8, and stamp it onto the frame with cv2.putText, positioned just above the box. Finally we show the frame with cv2.imshow, and we watch for the Q key with cv2.waitKey so the user can quit. When they do, we release the camera and destroy the windows. That is a complete, real-time scanner in well under 20 lines. Point it at a QR code and watch the green box snap onto it with the decoded value right there on screen. So what can pyzbar actually read? Quite a lot, because zbar underneath supports most of the barcode symbologies you will meet in the real world. QR codes, obviously. Then the retail family, EAN13 and EAN8, the barcodes on almost every grocery product, and UPCA and UPCE, common in North America. It also reads the code families used in logistics and labeling, code 128, code 39, and interleaved 2 of 5, often written as ITF. Remember that .type field on each result tells you exactly which one it matched, as an uppercase string. Now, here is a nice performance tip. By default pyzbar scans for every symbology it knows, which is a little wasteful if you only care about one. You can restrict it. Import ZBarSymbol from pyzbar.pyzbar, and pass symbols equals a list with ZBarSymbol.qrcode to decode. Now it only looks for QR codes. That is faster, because it does less work per frame, and it is also more reliable, because it cannot accidentally misread some pattern as a different barcode type. If you are building a QR-only app, that one argument is well worth adding. So what do you actually build with this? Once you can turn a camera into a decoder in a few lines, a lot of small, genuinely useful projects open up. An inventory scanner that reads product barcodes and logs them into a spreadsheet or a database. An attendance system where people scan a personal QR code to check into an event or a class. A ticket validator at the door that reads a QR ticket and checks it against your list, marking it used so nobody sneaks in twice. Or a little utility that reads a Wi-Fi QR code, the kind you generate to share your network, and pulls out the network name and password as text. None of these need a paid service or an internet connection. They are all the same core loop you just learned: grab a frame, decode it, read .data, and act on the result. The scanning is the easy part now. The interesting work is what you do with the value once you have it. Let's lock in the whole workflow. 1. Install is 2 parts, pip install pyzbar for the wrapper, plus the native zbar library on your system. On Windows that means the Visual C++ 2013 Redistributable, or you get that libzbar 64.dll not found error. On Mac it is brew install zbar. On Ubuntu it is apt-get install libzbar 0. 2. The import is from pyzbar.pyzbar import decode, with the name doubled. 3. Decode always returns a list, 1 entry per code found, and each has .data, .type, .rect, and .polygon. 4. And never forget this one, .data is bytes, so call .decode UTF-8 to get a real string. 5. pyzbar takes an OpenCV NumPy frame directly, so a live scanner is just read a frame, decode it, and draw the .rect box. And 6. Narrow it down with symbols equals ZBarSymbol.qrcode when you only want QR codes. That is barcode and QR scanning in Python, start to finish. If you want more practical, everyday Python like this, There is a free Python guide linked down in the description, and a Python Power Pack if you want to go deeper with snippets and interview prep. Now go point a camera at something and decode it.